So, today we will talk about acids and bases. Before we start, we must understand what is an electrolyte. Water solutions of electrolyte conduct electricity. Why? Electrolytes are compounds that break in water into ions. And as we know, ions are charged particles. So we have charged particles, and that's the reason why water solutions of these compounds can conduct electricity. Acids and bases are electrolytes. And so what kind of electrolyte is an acid? When we are talking about water solutions, acid is an electrolyte that breaks in this solution, giving hydrogen ions. For example, hydrochloric acid breaks into hydrogen plus ion and chlorine minus ion. And hydrogen plus ion we will call proton because it's only proton without any electrons. The same we can see with sulfuric acid. In water it breaks into proton and hydrosulfuric ion negatively charged, and this ion also can give a proton and a sulfuric ion negatively charged. But we need to notice that free proton exists only in vacuum. In water solutions it is hydrated, forming hydroxonium ion H3O+. And what is base? Base is a compound that reacts with an acid, making salt and water. There are bases that are soluble in water. They are called alkalis. And in water, they break into hydroxide ion and positively charged ions of metals. Here we see the equation when sodium hydroxide breaks in sodium plus ion and hydroxide ion that is negatively charged. Alkalis include hydroxides of metals of the group 1 and soluble hydroxides of the metals of the group 2. Acids and bases can react with each other. This reaction results in formation of salt and water. These reactions are called neutralization reactions. Here we can see examples. We can take sodium hydroxide and hydrochloric acid, and reaction between them results in making sodium chloride and water. We can write this equation in ionic form. Here you can see this equation in ionic form, and in the left and in the right parts of equation there are the same ions, sodium plus and chloride minus. So we can cancel them out, and what we get? We get reaction between proton and hydroxide ion that results in formation of water. All we were talking about is applied to aqueous solutions, to water solutions. And the theory that describes this process is called by the name of its founder, Arrhenius theory, because it was founded by Swedish scientist Svante Arrhenius. And now we will talk about more general theory, the theory of Brønsted-Lowry. This theory can be applied to reactions occurring in a different medium, not only in water. According to this theory, acid is a substance that loses proton. It is a proton donor. For example, hydrochloric acid gives a proton and a negatively charged chloride ion. As an acid, we can take also a hydroxonium ion because it can break into water and proton. According to this theory, base is a substance that accepts proton. For example, base can be ammonia, water that accepting proton forms hydroxonium ion. Carbonate ion also can be a base. Very important notion of this theory is conjugate acid-base pairs. When acid loses a proton, it also makes a compound that can accept proton, and accepting proton compound is a base. So it appears conjugate acid-base pair. For example, if sulfuric acid gives a proton and makes a HSO4 minus ion, this ion is an base because it can accept proton. So pair of sulfuric acid and this ion make conjugate acid-base pair because they can form each other. Sulfuric acid giving a proton makes HSO4 minus ion, and also this ion accepting proton can make sulfuric acid. So this pair is called conjugated acid-base pair. Here we also see another example of such a pair. So that's all that we have to talk about today. So we talked about what is acid, what is base in water solution and in different medium. We were talking about Arrhenius theory of acids and bases and Brønsted-Lowry theory. And we began with the notion of electrolyte. We defined what is electrolyte, and on this notion is based all that we were talking about today. So see you in the next videos.